Okay, this is the start of the getting started portion of the heat loss project for number 81. The first thing we're going to do is take a close look at the example calculation for the basement, and we'll just bring that video up here in just a second here. Okay, so here we are. This is the basement and foundation plan in your project instructions, and you will see that we have the sliding door area here. I guess you could call that just a little outdoor patio perhaps. We've got a wall that's 3 feet is exterior dimension there, 4 feet there, approximately 9, possibly closer to 10 feet across here. And then, as according to the dimensions of the recreation room, we have 20 feet here and 13 feet here across to this room. Now this portion is what's exterior dimension. So a few things that we need to notice that we're going to be using is, first of all, the dwelling location is in Surrey. So in this case we'll be looking up the design outdoor conditions for Surrey so that we can find out what our delta T is going to be. We also have a list of R values here for this particular portion of the structure. We show the walls are R14 and they're all above grade. There is a slab on grade floor and it is detailed as R12 edge, so that would be insulated around the edge. And we'll be looking up those items on our heat loss factors sheet, which comes with this, as well as our double glazed with a 1/4 inch airspace windows. All of this information, of course, you can find at the bottom of this screen, at the bottom of this page, labeled 1-9. The next portion of this we'll see is we've got to look at our sheet of instructions. So if you look at this page, you'll find that it's labeled 1-2, and it starts off step by step. So we're going to enter our project details in the title block, which is at the top of our heat loss page. We're going to enter the outdoor design temperature from January 2.5% column of the design temperature chart. In this case we're looking for Surrey, and so if we look up for our location of Surrey on page 1-4, we'll see that it says 17 degrees under the January 2.5%. So that's the number we're going to use for our to calculate what our difference in temperature is across the wall segments. So that shows we're going to enter our room temperature set point as well, and that's going to be entered as 72 degrees Fahrenheit in the appropriate box. We're going to enter the difference between the outdoor design temperature of 17 degrees and the room temperature of 72 degrees, and we'll come up with a difference of 55 degrees, which is going to go in our chart. So for the remainder of this, we're going to look at this spreadsheet, which is a direct representation of the worksheet that you'll be recording your information on, and we'll just overview where we got some of this information. First of all, we're dealing with Surrey, which is located up here. The outdoor design temperature is 17 from the chart, or table I should say. Room temperature is 72. And we're also going to enter 160 degrees as an average supply temperature for a warm air furnace, and also a baseboard output per foot of 400 BTUs. That will come in handy later, and we'll show you exactly how that works out. So one of the first bits of information we have to fill in is we have to fill in the glass or / door U factors, apply our temperature difference to it, and come up with a multiplier for glass and doors. This multiplier will be used to find out your total BTUs per hour transferred through the different materials per square foot. Okay, so our U factor we get derived from our heat loss tables for our heat loss factors for different materials, and this is page 1-5. and you'll find windows there, 1/4 inch airspace, double glazed in the top left portion of the table, and that shows a value of 0.65, so we record that right there. We already know that our temperature difference, 72 degrees subtracting 17 degrees is 55, and so that goes there, and you'll see that we duplicate that all the way across. So when I make the multiplication of 0.65 times 55, I come up with a multiplier for glass and or doors of 35.75, and that number will be recorded in there. Next we look at our above grade wall, and we look up on our heat loss factors chart again for page 1-5, and looking at the R14 insulation frame above grade, that shows a U factor of 0.06. That is recorded at the top. Our temperature difference remains the same. We multiply these two and we come up with a multiplier factor for the above grade walls of 3.3 BTUs per square foot. And we're going to use that later when we calculate our total wall. Now, the only other item that's on this list that it will be there that we need to worry about is the slab edge. So when we look up the concrete slab on grade from table 1 on page 1-5, we'll see in the bottom right hand corner there's C, concrete slab on grade, and it shows two different values there, one for 1-inch edge insulation and one for 2-inch edge insulation. Per linear foot of R12 would be 0.53 as a heat transfer factor, and so we put that there, or U factor. Then we have our difference in temperature once again, and we multiply the two and come up with this multiplier of 29.15. Okay, so we'll be using that down below here. Okay, so the exposed walls overall, we do need to add up our exposed linear length of exposed wall for the rec room. We have a room dimension of 13 by 20, but we also have that small inset that is open through the sliding glass door. Now I'm just going to return to that picture for a moment, and there we are. And so this is the little cutout area here. All of this is in addition to the 13 by 20 as I am interpreting this picture. This area in here being described by my cursor is 13 by 20. But of course this portion here is in the upper left is a exterior wall, as is this portion, and the little 3-foot portion at the what looks like a stair landing. All of that is exterior wall. So in the process of adding those all up, and we come to this total of 50. Now, to be perfectly honest, when I calculated it up, I came out with 49.5. The exercise is using 50. There may be a reason for that, which I will hopefully be able to clarify later. Then we have 46. Number 46 is listed here. This is an actual area of glass, right? So it's under our glass column, and that 46 represents the addition of the two windows that are in our example. One is 12 square feet and the other is 34, and those added together come to 46. Now when we subtract that area from the actual wall area, and we get the wall area by taking our 50, multiplying it by the height, so we have an exposed wall length of 50 feet, and all of that wall is 8 feet, so we're going to multiply that and then subtract from that the area of our windows. We will end up with 354 square feet of above grade wall. So that's our 354. Now when we use the multiplier that's associated to the above grade wall of 3.3 times 354, we'll end up with this total of 1,168 BTUs per hour. Over to in the column to the left of it, we show our glass at 46 square feet with a multiplier of 35.75, and that multiplied will come out to 1,645 BTUs per hour. We don't show any other items here for that room other than the slab edge, and the linear edge, of course, would be the outside the outside linear exposed walls, linear length. And we have that calculated at 50, and we're going to multiply that by 29.15 because this number is based on per linear foot. So we multiply it by the linear length of the exterior wall, edge of slab I should say, and we end up with a total of 1,458 BTUs per hour. Now I've reoriented our view to look at the latter end of the worksheet under room volume and air changes per hour. We determined, because of the type of walls that we were looking at, that we should be looking at about a 2/3 air change per hour. Now all of the other information that's on this line is based in per hour numbers. So there's a little bit of math that has to be done here. It's not too complex, but what we're doing is we've developed a multiplier for 2/3 of an hour, and we've developed a multiplier for half an air change per hour, and there's also one here for 1 full air change in an hour. So we use that number first to get the total BTUs per hour that would be transferred using that air volume of 2,080 cubic feet. And then, so that gives us a total number for an hour, but we're only actually losing 0.66 of that. So we multiply that number. Once we get 1 times this number of BTUs per hour, we multiply that by 0.66, and we end up with a figure that works out to our amount of heat lost in 1 hour, and that keeps us in line with all the other BTU per hour losses that are on this line. So we can add that all up, which is what we do to get this final number here, total BTUs that's in this cell here. So what that cell is, and I'll show you a little precedent function here that is handy for showing up what's the product, what all add up to these. Well, it's this value here as well as any of these others, which of course are zeros, but our initial BTU numbers that we came up with for the rec room, for the windows and for the wall area. So that's our total there. So then the next step here is to go on to the next room, the family room, and we'll work that one out the same way. I have a sheet of answers for that, and we will try to achieve the exact same answers for that one when we attack that in class. Okay, thanks.